So what happens if instead of having just a wire, we have a loop carrying a current I? For example, like this rectangular loop here, starting A, B, C, D. And it is carrying a current in the counterclockwise direction. You see the arrows here pointing to the direction of the current. Let's focus on segment CD. Now, for segment CD, if we subject that loop to a magnetic field, as represented here by the pink arrows, it's pointing towards the right of the screen. So the current is pointing to the left of the screen. The magnetic force acting on the wire should be IBL sine theta, where L is the length between C and D, but then theta is the angle between I, the current, and B. In this case, B is pointing towards the right, I towards the left, so the angle between them is 180 degrees. So the force acting on that segment is 0. Same thing for the segment AB, except the angle is going to be 0 degrees in this case, and the force is going to be 0. Now, for segment DA, in this case, the magnetic field is pointing, we have the hand there, it's pointing towards the right of the screen. The current is pointing down, so the force is perpendicular to the screen, pointing towards you. It's pointing out of the page. For segment BC, same kind of idea, but the current is pointing up right now, so your thumb should be up, your fingers should be this way, so the palm is pushing towards the screen. So the force is pointed towards the screen. So if we have a side view, for segment DA, the force is this way. For segment CB or BC, it's pointing that way. The net force acting on the loop is 0, since these two forces are equal to each other. Why are they equal to each other? It's I BL sine theta. Theta in this case is 90 degrees. So in both cases, IBL, both segments have the same length. So we have the same force. So equal forces, opposite in directions, they balance. So the loop is not going to move anywhere, except the net torque is not 0. This one is trying to rotate it clockwise, and this one is trying to rotate it clockwise about the center of mass. So this leads us to think that the loop might spin, and we might be having an electrical motor here.